Now I want to look at something called symmetry. And with symmetry, you want to think about mirror images. If something is symmetrical, it means it's the same. So symmetry occurs very often in nature. If you think about a butterfly, right, it has symmetrical wings. Even our faces, although it's not perfect, we're pretty symmetrical, right? Our left side and our right side of our face are pretty much the same. So they do occur a lot in nature and in art, and they also occur a lot in mathematics. So there's lots of different kinds of symmetry, but in math, there's some special cases that we talk about. So that's what we're going to look at here. So symmetry with the y-axis is one kind that we focus on a lot. And I'm just going to show you a picture of something that would be symmetrical with the y-axis. Okay. So something like this. So if you were to fold along that y-axis here, right, you would see that those two halves would match right up. And that's a great way to check for symmetry. Just fold that paper right in half and you'll see those two sides would match right up. So this is something that has symmetry with the y-axis, or symmetrical or symmetric with the y-axis. So you have that mirror image over the y-axis. Graphically, what you're going to see is that every point xy on the graph also has negative xy in the graph. So for instance, I'm just going to make up the points here, but let's say this was the point 1, 2, then you would have the point -1, 2. So you'd have the mirror image of the point on the other side. The y value stays the same, but you'd have opposite signs for the x's. You can also see this algebraically, meaning like if we actually solving it by hand, by replacing x with -x to see if you get the same equation back out. So if you were to plug in -x and you simplify, you should get the original equation back out. Okay, and we're going to do some of that in just a minute. Another type that we see often is something that is symmetric with the x-axis. Okay, so something like this. So you can see that you have a mirror image over the x-axis. So if I were to fold my paper right along that x-axis there in half, so fold it this way, those two sides are going to match up. What you see on a graph is that for every point xy, the point x negative y is on the graph. And again, I'm just going to make up some numbers here. Let's say this is the point 1, 2, then this point down here would be 1, -2. So opposite idea of the last example, you have the same x value and then you have both versions of the y value. If you're going to do it algebraically, and I'll show again, we'll do this in a minute. What happens is when you replace y with -y and you simplify, you actually get the same equation back out. And the last one is probably the toughest to see. This one is called symmetry with the origin. And here's a classic example. Something like this. So it almost looks like it does a double flip. So the pieces have flipped both along the x-axis and the y-axis. So if you were to fold your paper, along the y-axis this way, and then again in half along the x-axis, those two halves should match up. So think about it. If I flip this one over the y-axis, it would be like this, and then I would flip it down and it would match this side. So it's almost like a double flip here, or a 180-degree rotation. So kind of twisting this 180 degrees, half a circle all the way around. What you see is that for every point xy on the graph, -x, -y is on the graph. So for instance, let's say this was the point 2, 8. I'm just making this up. Then this one down here would be the point -2, -8. Okay, so you have very similar points, but the negative signs change. How do you check this algebraically? What you do is you replace both x and y with the negative counterparts and see if you get the same equation back out. Now, I will note that you can have more than one symmetry. So for instance, something like a circle that is perfectly centered at the origin would have all of these symmetries. It would be symmetric with the y-axis, the x-axis, and the origin. So you can have more than one symmetry for your examples. It really just depends on the problem. So you want to check them each individually. You don't want to just say, oh, well, it has symmetry with the y-axis, I'm done. You still have to check all symmetries if that's what the question asks you to do. All right, so let's look at a couple of those examples. So determine whether this graph here is symmetric with the y-axis, the x-axis, and or the origin. So I'm going to check the symmetry with the y-axis first. So what you're going to do there, if you forget, the directions are here on the page before, is you're going to plug in negative x instead. So I'm going to go here. I have my original function, and I'm going to replace x with negative x. And then if you can, you would simplify. So here I can't simplify at all. And you see, did you get the original function back out? So this is not the original equation. So not symmetric with the y-axis. Okay, so you should get the same equation back out. All right, let's try the next one. Let's see if it's symmetric with the x-axis. So what you're going to do there is plug in negative y for y. So I start with my original example. I plug in negative y for y. And what happens here is, well, negative y squared is the same thing as y squared, right? That negative will cancel. And this is the original equation. So it is symmetric with the x-axis. And then I can check the last one. So we're going to replace both x and y this time. So I start with the original equation, replace both with their negatives, simplify as much as I can, but the problem is I'm still going to have a negative left over here. So this is not the original equation. So it is not symmetric with the origin. So here we only have one symmetry. We see that this equation is symmetric with the x-axis. Okay. The other thing you can do here, and I won't do it in the video, but you can go to Desmos. You can graph this and see what the graph looks like. If you graph this, you are going to see that it will have symmetry with the x-axis. It kind of looks like this graph right here. It's not obviously the same exact points, but you have that same shape. So if you graph it, it's a good way to check your work here, is you will see that it's symmetric with the x-axis. All right, let's try another one. So I'm going to check, see if it's symmetric with the y-axis first. So remember, I'm going to plug in negative x here. So y equals negative x cubed instead, which is y equals negative x cubed, right? This is not the same. So it's not symmetric with the y-axis. I'm going to try the next one here. Symmetric with the x-axis. So I plug in negative y. So I go back to my original, I replace it with negative y. No simplifying to do here. This is also not the original. So it is not symmetric with the x-axis. And finally, I'm going to try the last one, where I plug in both Go back to the original, and I replace the y with negative y and the x with negative x. I'm going to simplify here. Well, negative x cubed is just negative x cubed. And what I could do is I could divide both sides by -1, and I get y equals x cubed. So notice this is the original equation. So we are symmetric with the origin here. So remember, just make sure you check each of the symmetries individually. I don't have a major shortcut there. The only shortcut would probably be to graph it. If you're good visually, then you could check your graph and make sure you do see that symmetry. Symmetry with the origin is a little harder to see because you have that double flip or that 180-degree rotation, but it's still a good check. So I would do it by hand and then go in and graph and check your work that way. Now, related to symmetry is the idea of even and odd functions. They really are almost the same thing. So functions that are specific, so I will say symmetry works for things that are not functions as well. So the terms even and odd, we tend to only use with functions, but really the checks above here work for any sort of equations, whether they're functions or not. For functions, if something is symmetric with the y-axis, we tend to say it is an even function. And if something is symmetric with the origin, we call it an odd function. So there's really nothing new there. It's just kind of a renaming. Now with even functions, another way to check that symmetry is to check this. So again, you're looking at symmetry with the y-axis. So remember here, we were plugging in that negative x. So here you're plugging in negative x and you're getting the original function back out. Now with odd functions, you're looking at symmetry with the origin. So what happened there is you needed both x and y to be negative to get the original function back out. Another way to think of that is that when you plug in negative x, you get the negative of the function back out because you need the y to be negative. So when I plug in negative x, I would need a negative y here to make the original function again. So it's just a different way to check. So when you plug in negative x, you're looking to see that the negative of the function gets spit back out. So when you have the negative of the function, it really means that all signs change. Okay. All right, so these ones I'm just going to draw in. So let's try it with the graph first, and then we'll look at some more examples here. All right, so let's see, example A. All right, so we want to determine if the graph is an even function, an odd function, or neither. Okay, so what you want to remember here is that even functions are symmetric with the y-axis. Odd functions are symmetric with the origin. And neither functions are just neither even nor odd. They could have a different kind of symmetry or they could have no symmetry at all. So it's just, they're not one of the, they're just not one of these two. So if you look at your first one here, this actually is symmetric with the origin. Okay, because you get that double flipping, right? If I were to flip this first over the y-axis and then down on the x-axis, they would meet up. I have this kind of 180-degree rotation here. So if I were to take this and turn it around, it would match up with the other side. So you have symmetry with the origin. So something like this is an odd function. It's also a function because it does pass the function notation. So I will note that as well. Now notice here, you have symmetry with the y-axis. If I were to take the left side and the right side and flip them, they would meet. So this is symmetric with the y-axis. So if you are symmetric with the y-axis, then you are an even function. Now this last one is not symmetric with the origin, and it's not symmetric with the y-axis. So we just say that it's neither. It's neither even nor odd. It doesn't mean it's a bad function. It just doesn't have these specific kinds of symmetry. This one here, it does kind of have its own symmetry, right? If you look at it this way, it would be symmetric along that line. You have this nice kind of, I know our picture's not perfect, but you know, a nice symmetry there, but it doesn't have a special symmetry with the y-axis or the origin. So it's just a neither. So your neither examples could have a different kind of symmetry, or they could have no symmetry at all, just be totally, not random, but you know, not super like a mirror image or anything like that. Okay. Now you can also determine if functions are even or odd algebraically, meaning like doing the math out by hand without just looking at the graph. I do think the graphs are a great way to check though, so it's a good habit to get into. So how do you check algebraically? So what you always do is you plug in negative x, and you're going to simplify and see what happens. If the original function is returned, then you have an even function because you're seeing that f of negative x is the same thing as the original function. If the opposite of the function is returned, so all signs change, the function is odd. And then if neither of those things happen, then you have a neither function. So if you're determining this, remember you're going to plug in negative x for this kind of test. So for A, I'm going to replace this with negative x, and then I'm going to simplify and see what happens. So negative x cubed is just negative x cubed. Here I have a positive 6x. Okay. So notice, first of all, it's always easy to check for even first. This is not the same as the original function. So this is not the original function f of x. So it's not even. But notice that all signs changed, right? Notice on the right, my positive went to negative and my negative went to positive. So when all signs change, then we have an odd function. Because basically you're getting the negative of the function back out. We're seeing that, well, when we plug in negative x, we get the negative of the function. The whole function changes signs. So that is an odd function. This one here is odd. For the next one, I do the same thing. I just plug in negative x and I see what happens. So here, negative x to the fourth power, all my negatives would cancel. So I would have x to the fourth power minus 2. And then here, negative x squared would just be x squared. So notice that I have the original function back out. Well, I guess I should be using g here, right? So we'll just change this to g. So this is the original function, in which case it is even. Okay. If something is even, you don't have to check if it is odd. Okay, so you're not going to check both of those. You're just going to plug in the negative x, and it's either going to be even, odd, or neither. And then for the last one, plugging in that negative x, and I'm going to simplify. Here I have a positive x squared. Here I have to keep the negative, negative 2x plus 1. So notice that this is not the original because my 2x went from positive to negative. So it's not the original. So it's not even. And also notice that not all signs changed, right? See how the 2 changed signs, but the other numbers did not change signs. So if not all signs change, then it's not odd. So this is an example of a neither function. So this video really focused on symmetry. So looking at the graphs and also equations. So keep in mind you have your tests for symmetry, which test any graphs, not just functions. So any sort of graph or equation can be tested for symmetry. And we talked specifically about symmetry with the y-axis, the x-axis, and the origin. And then specifically for functions, when we talk about symmetry with the origin or with the y-axis, we rename them as odd and even functions. So we did talk about how to test for symmetry there as well.